little button at the bottom for the Q&A chat that you'll click that, press that, and you'll send to the speakers. At this time, I'm going to hand it over to Ken.
Thank you, Lawden. Good morning or afternoon, everyone. Thank you for attending the June webinar sponsored by SPSP. My name is Ken Ross. I'm the webinar coordinator for SPSP and also serve on the board. And I want to thank Sedgwick Brand Protection for sponsoring this year's webinars. They've done this in the past, and we thank them for their support and look forward to working with them in the future. Let me discuss our upcoming programs. Next month, we will do a program on selling product safety to the C-suite, and we've got 3 great speakers, all of whom have been in charge of safety and compliance and have reported into the C-suite or actually been in the C-suite, one of the two. And that's an interesting issue to try to figure out how do we justify the expenditure of a bunch of money to companies that haven't had a bunch of product safety problems before. We'll talk about that. Then in September, we'll take August off. And then in September, I'm rescheduling the process control program, which we unfortunately had to cancel last month. And there, we've got 2 great speakers, and we will focus on manufacturing defects, which is pretty detailed stuff, and the role of a product safety professional in trying to be sure that our companies don't sell products that have manufacturing defects. So we'll be talking about that a little bit today, but from the safety side, our speakers are more acute quality control experts and can talk about what you as product safety professionals need to be aware of and pay attention to as you're designing and making products. We have 2 great speakers today. Al Pierga, who is the Vice President, Product Safety and Regulatory Compliance for SharkNinja. Al has spent his, I guess, almost entire career in product safety, and previously was the Director of Product Safety at Bosch Tools. Mark Hickok, you all know, Vice President, Product Safety Regulatory Compliance for Milwaukee Electric Tool, and likewise has been doing this forever. So 2 great speakers. And one thing I'll point out, now they work for companies that basically make finished products, but we're going to talk about the subject whether we're on the OEM side, the finished product side, or whether we're on the component part side. And as you'll see, that's a bit different. Both the law and product safety principles can differ depending on what side you're on. Me personally, having worked for Westinghouse Electric and Emerson Electric, we both made components that goes into finished products, either made by our company or made by another company, and also have made finished products. So it's very different depending on which perspective you're looking at, which makes me very interested in the topic. It's very complex and very interesting. Now, we will post these slides, but actually we're going to post a little bit more complete slides. So there'll be more slides in what we post that we're going to have a chance to show today to give you a more complete picture of some of this stuff. And secondly, not a big surprise, I've written an article on this subject, which is very detailed and gives my thoughts on how you are, from an OEM side, from a component supplier side, how, from my perspective, you can deal with this issue. So I'll post that article and a more complete set of slides. And there may be some other things we put in there, but those are the main things that we will have. So let's talk about this subject. I'm going to give an intro on the legal side and with my 2 cents on what you should do, and then I'll turn it over to Al, and Al will turn it over to Mark. The reason I love this topic is, and as all lawyers do, is we love complex facts, because that's what we get to do, is discover the facts, try to figure out what they mean, whether we're about ready to sell a product or we've sold a product and have to worry about a safety issue and worry about a recall and who's responsible, or whether we're sued in a lawsuit. Either way, whichever is happening, the more complex the case, the more parties that are involved, uh, the more interesting it is for us. Less interesting for you all product safety professionals. That makes it a lot harder to figure out what to do. So and this is just a simple slide here. I mean, we've got OEMs, and we always, of course, refer to our suppliers, particularly in complex products, tier one, tier two, tier three, tier four. And I've done work for tier six suppliers. So they made little computer chips and they sold to a tier five, and the five sold to the four, and the three, and the two, and the one. And it was in an automotive area, they were complaining because the automobile manufacturer would recall their automobiles based on a defect in a tier six uh, product component and never bothered to tell them they were going to do that. And so the complexity of products, particularly with industrial equipment, automobiles, is really enormous. And both from a safety standpoint, it's very interesting. And as we'll talk in just a moment, the contracts get really interesting too between these various parties. So the more tiers you have, the more complex it is. And then when something goes wrong, the more difficult it is to figure out what's going on. One of my first product liability cases involved the crash of a DC-10 in Paris, France, and everybody who sold components to McDonnell Douglas got sued. So trying to figure out who was responsible, what happened, who's responsible from a safety standpoint, who's responsible from a financial standpoint, was real complex. There were, hundreds and hundreds of suppliers in that situation. I've done work for a steering column manufacturer for an automobile, and there are 1,400 components made by other companies in that steering column. And the OEM of the steering column gets to specify and buy and assemble all of those parts. And then they get put into an automobile. So when something goes wrong with the steering, trying to figure out who is responsible from a factual standpoint, can be very complex. One other example that I've had in my experience, at Emerson Electric, we made thermal cutoffs for various products. And we sold the thermal cutoff to a coffee maker manufacturer who installed our thermal cutoff, and it wasn't working, and there were a bunch of fires. And the coffee maker manufacturer came to us and they were going to recall the product, and they wanted us to pay for it. Well, we tried to figure out what was going on, and it turned out that the coffee maker manufacturer was installing our thermal cutoff incorrectly. So we said, hey, wait a minute, there was nothing wrong with our thermal cutoff. You installed it incorrectly. And they said to us, well, you never told us how to install it. And, my response was basically, hey, you're the world's biggest coffee maker manufacturer. You ought to know how to install our component, or you should have asked us. But we didn't check on it. We assumed they knew what they were doing, and we didn't think we needed to provide any instructions on how to install our product. Those kinds of cases are really troublesome, because you're pointing fingers at each other. And there's one thing the plaintiffs love to have is multiple parties in a lawsuit pointing fingers at each other, because they can just sit back. They don't care where the money comes from. They got one party building a case against another defendant and build it for them, and they don't really need to do much. So in these component cases where we're not just plaintiff versus one defendant manufacturer, they get very complex factually and contractually and insurance wise, and trying to figure out who's responsible can be a real trick. So let's talk about the law in general. The law is pretty clear. OEMs are liable for the finished product and all components and raw materials in that product. That's easy. It makes sense. Seems fair. And why is that? Well, it's because the OEM gets sued, and the plaintiff doesn't know which component might have caused the problem at that point. So they don't necessarily have to sue every component manufacturer. They don't even know who they are. or what exactly caused the product. So they sue the OEM. At that point, the OEM then might sue a new lawsuit, or is part of that lawsuit, the component manufacturer whose component caused the problem. So sometimes that happens, sometimes it doesn't. Sometimes the OEM defends the case, and and if they lose, then they try to get reimbursed by the component manufacturer. A lot of times, the component manufacturer will be brought into the case by the OEM or by the plaintiff. And then again, people start pointing fingers at each other. So the OEM is always going to be liable for the finished product, no matter what the component did. The only difference would be is if the OEM can then prove that the component caused the problem, and they really shouldn't be responsible for it. And that's a factual question. But a lot of times contracts enter into it, and contracts are a big part of this. And so if the OEM is protected with a contract between the OEM and the component supplier, whether it's an accident or a lawsuit or a recall, then that enters into it. A lot of situations come up where either the component supplier can't be sued in that jurisdiction, or the component supplier is a foreign company that one can't be sued. Or we've had other situations where the component supplier basically isn't in business anymore. So in that case, the OEM is responsible for everything. So, but sometimes you have a contract. The contract may be helpful, and the component supplier may defend the case or take care of the recall in that case. But the contract between the parties, if there is one, that deals with indemnification and recalls and lawsuits, would govern then who's responsible for that. Now, the component supplier may be protected by contract with the OEM. On the other hand, the OEM might be protected by contract. So it's a matter of who has kind of market power and trying to figure out whose contract applies and which one protects, which party is protected from that contract. Now, when you start dealing with tier 2, tier 3, tier 4 stuff, it gets really complex because now we have contracts between the OEM and the tier 1 supplier, and a contract between the tier 1 and tier 2 supplier, and tier 2 and tier 3, and down the chain. So you could have 5, 6 contracts to worry about to try to figure out, well, who's ultimately responsible here. Gets very complex, can get very complex. Now, depending on the jurisdiction where a case is brought, if there's a lawsuit, there could be a joint and several liability, or the jury can decide the percentage of liability, which could have an effect on then who's ultimately responsible for it. So the law is pretty flexible on this and understands how complex products are, and provides an opportunity for a jury to decide who's ultimately responsible if the component supplier is there. But if a component supplier is not a party in the lawsuit, they're out of business, they can't be sued, they're a foreign company, then the OEM stands in the shoes of anybody who sold a component or raw material in that product. Now, the raw material and component part supplier could be liable if they can be sued in that jurisdiction if the component or raw material is defective, the defect caused harm. That makes sense, and that's pretty easy. But they also could be responsible if the component part manufacturer substantially participates in the integration of the design of the product, and the integration makes the product defective, the defect cause harm. So the example of that is I am an OEM and I want to buy a component part from a manufacturer, and I don't know which component part to buy. So I go to the component part manufacturer and I say, well, here's my product. I looked at your catalog. I don't know which part I want to buy, and I don't know where it goes and how to install it. So what do I do? So if the component part manufacturer recommends the component part that goes in the finished product, and it's the wrong recommendation and it's the wrong component part for that use, the component part manufacturer can also be responsible in the event that the component part caused the problem. Now, what that law does is it kind of discourages component part manufacturers from helping the OEM pick the right component part. Now, Al and Mark are going to talk about this because, obviously you want to have a component part manufacturer who helps you figure out what component part to put in the product. So, but the lawyers at the component part manufacturer have been known to recommend to their companies, don't make any suggestions. We give them the catalog. You can look at the catalog. You, OEM, you get to decide what component part goes in that product. We're not going to make a recommendation. So that gets difficult if if they make the wrong selection from either the OEM side or the component parts side. So sometimes the law discourages actions by one side or the other, which is not that helpful from a safety standpoint. So you're the OEM dealing with suppliers. So I'm the OEM, I'm buying components. You got to decide which ones am I going to buy, which ones am I going to make myself, which suppliers do I have? Do I have multiple suppliers? Is this a safety critical part, raw material, and service? Now, interestingly, because of that law, it's an interesting question whether the OEM wants to help the component part supplier design their component part. And of particular interest to me, what is the role of the OEM in being sure that the warnings and instructions supplied with that component part are adequate? Do you really want to do it? So the more the OEM gets involved in the design and the warnings and instructions on that component part, the more they're responsible for the ultimate component part. And so if that component part was designed incorrectly or there were inadequate warnings and instructions, they can't blame the component part manufacturer because they're going to say, hey, wait a minute, you approved my design, you approved my warnings and instructions. So if there's something wrong with any of those, you OEM are responsible for it, not me. So there's a lot of tension, can be a lot of tension between an OEM and a component part supplier because each of you are trying to protect yourself in the event something goes south after the product is being sold. So there's both the legal side of it and the contractual side, the insurance side, and the safety side. And I will say there's sometimes they don't match up as far as the encouragement of what's going on. So now so we, as a result of this, we the OEM, we're trying to obtain contractual and insurance protection. We're trying to figure out if that really protects us, whether it's adequate, and in what situation will it protect us? Again, the more involved the OEM is in the component part of this, the more likely they are to be responsible, and they cannot blame the component part supplier. Lastly, you don't want to rely on contracts and insurance to protect you. You as an OEM, you want to be sure the components you buy are correct, they're installed correctly, and that they are safe for their intended use. Now, on the supplier side, it's very different. Do I want to assist the OEM with a selection of appropriate components? I think you do, but some lawyers are going to say, no, we don't want to help because the more we help our OEM, the more responsible we are. We want to confirm the components being used correctly and installed correctly. That's my coffee maker example. Should my company have been sure that the coffee maker manufacturer both selected the correct thermal cutoff and installed it correctly? Well, on reflection, yeah, we probably should have done that. Should we have had to do that? No, we shouldn't have had to do it. They were a coffee maker manufacturer. They should know about it. One thing that's very interesting to me is I'm an OEM, I'm buying component parts. What if I find that the warnings and instructions of my component part supplier are inadequate? They don't meet the standard, they don't meet the ANSI standard. What do I do? Do I tell my component part supplier that they need to redo the warnings and instructions? Do I need to have them hire a warnings expert to come up with better warnings and instructions? Or can I just take a component part with inadequate warnings and instructions and pass it through to the user and figure that if there's some problem, I can blame the component part manufacturer? Now, that may not work. I don't like doing that. On the other hand, it's a difficult question to figure out, do I go back to the component part supplier and have them improve their warnings and instructions? So, and then the last area in trying to deal with this concept is how how much do I want to be sure that my OEM is going to tell me about any problems that might be attributable to the component that I've sold them? In that situation, the OEM could report to the CPSC, undertake a recall, and not even tell me about it, as we had with the coffee maker recall. The coffee maker manufacturer did the recall. It was almost done, and then they told us that they wanted us to pay for it, and it didn't involve us at all. So how involved should the component part supplier be in the determination of whether there's a problem here, whether it should be reportable to the CPSC, whether a recall should be undertaken? So, closely working between the OEM and the component supplier, I think is important. We're working together on these things, but a lot of times, particularly when we got tier 1, 2, 3, 4, 5, it doesn't happen because everybody's in their own little world and working, independently of each other and don't really think through the entirety of the production chain and all the relationships between the parties. So it's a very interesting issue. This subject is discussed more completely from my perspective in the article that I will post. And I'm going to turn it over to Al to talk about specifications, and then Mark will come in and talk about supplier evaluation and selection. So Al, you're still there, I hope.
Hey everyone. Thank you, Ken. So I'd like to start a little bit with the perspective of how this all impacts, what we do. We clearly work for companies that are looking to get to market and really work with customer needs and all that, but really not taking care of and building in these controls can really result in real consequences for the business and everyone else once the product is launched with some deficiencies. So the critical thing to remember, I think, when you go over to that the left, is that how important it is to take care of building in the controls into the design and what impact it has. Clearly, just simply illustrating in the cost to fix things, you have order of magnitude increase. I mean, these are just some numbers, right? But just to get a perspective, it becomes tremendously much more expensive as you progress through the development and into production to take care of something that could have been easily addressed up front with the proper due diligence and specifications that can be well controlled. And it starts with advanced development, doing a proper risk assessment, identifying the hazards and measures, and building in an infrastructure into the product where all that is taken care of through design, guarding, warnings, and instructions as appropriate. And the responsibility isn't just like typically you may find that everyone's looking to safety to just create that. This is a collaborative effort. and when it comes down to dealing and collaborating with outside suppliers on parts, that becomes even more important to make sure there's clear communication and expectations are well managed. Which also going in reverse, as Ken mentioned, being a component supplier, you need to clearly communicate boundaries and kind of the operating parameters that are acceptable and communicating any specific technical limits. So it's important that the communication is clear and there's clear alignment between all parties to emphasize the important safety elements in the design. Can you please switch to the next one? So what are this? So one thing that is important in there, right, is to make sure specifications are written very clearly. And that really sets the stage for everybody to align and understand what the expectations are all the way through the product. Things like physical characteristics, size, weight, color, chemical makeup, material properties that you're looking at, any performance specs that you're looking at, and the life. Because then one thing to remember is that the expectation is the product remains safe through the life of the product. Often the question is, well, is it warranty? Is it, maybe 5 years past or whatever that is? I think that, it's important to keep in mind that it should be through the useful life of the product, whatever that may be. It has to be clearly defined, and then we can work from there. Next, please.
Oh, oops, sorry.
That's okay.
Yep.
So further on the specs, basically we're looking at, the standards that we have as underpinning within the organization. What are your engineering standards to make sure that they're suitable for specifying these critical parameters that need to be maintained to maintain safety? Any models that you develop, drawings, how well they're specified, anything that we need to implement in terms of specifying critical dimensions or maybe critical functions, all those attributes, processing also, material specifications, all that is important to capture and clearly draw the line of what is acceptable and how good it has to be to meet the objective. Of course, applying external standards that are applicable. Sometimes the standard may not be entirely applicable, but you want to apply, the elements that would be reasonable in the case that you're dealing with to mitigate hazards, right? So there are some good engineering solutions throughout the industry that address many challenges that we're still seeing and we'll be seeing for a while. So that's a great resource to really know those and apply them appropriately. Of course, the federal standards we are obligated by law to comply with. The CPSC governs certain product categories. FCC applies rules in many ways. FDA, for example, you got FDA with lasers, right? I mean, you don't think FDA is with lasers, but they do that. I mean, so we got to be very familiar. And prior to implementing a technology, we need to understand the obligations that apply. Color coord. I mean, just anything we're looking at the Z535 is as that apply to warnings and communicating messages to the customer. That all has to be, or the user, that all has to be very clear. And of course, there are plenty of customer requirements. So the customer requirement could be, depending who you are, could be the final OEM, or it could be the retailer, or it could be the end user. So that's very important to capture that and stratify them to make sure that those are clearly identified upfront and any safety relevant elements are properly addressed. Next, please.
Can I jump in? A couple, two examples. I mean, one, I've had, again, in my in-house life, customer requirements where the customer wanted us to revise our product in a way that we didn't think made it safe. And we'd argue with them about it, but oh no, we want you to do it this way. So as a component supplier, you either need to protect yourself or you need to not do it and turn down the sale. So you got to decide what require, you can't just sort of, a lot of OEMs, they'll think, I'm sorry, a lot of component suppliers think, well, if I just comply with customer requirements, I'm in good shape. Well, not necessarily. There's actually a famous situation where the component supplier, actually it was a raw material supplier, got stuck defending a bunch of lawsuits because the OEM went out of business after the first lawsuit. So you never, it's like be careful before you comply with customer requirements, whichever side you're on. That may not necessarily fully protect you, and if you don't believe it provides a reasonably safe product, you want to be careful about it. The second example is I did a project for application engineers for a component. And they were concerned because customers would call them and they wanted a recommendation on the component, but the OEM didn't really have enough information about where exactly it was going to be used and what temperatures and pressures it was going to be subjected to. And so they wanted a recommendation, and these application engineers said, well, I don't want to get in the way of a sale, but I don't feel comfortable making a recommendation. I don't have enough information. So on the OEM side, you also got to be careful if you are going to make recommendations that you understand these specs and that you're relying on these specs, and you want to make it clear my recommendation is based on the specs provided by the OEM. I'll stand behind that. But if it turns out that the specs change or the OEM changes how you're going to use that component part, that you're protected and you can say, well, yeah, my recommendation was wrong, but you gave me the wrong information. So, I don't know how else you do that other than be careful before you make recommendations. And secondly, make sure it's clear between the parties what that recommendation is based on and the basis of using that particular component in that application.
Excellent points.
Okay, next slide. Good.
Yes, please.
Oops, sorry.
So moving on to a little bit more, get more granular here, is that there are multiple ways to specify products, right, and different control methods that we can apply through the process. Oh, the previous one, please.
Sorry about that.
So some things, there's a clear list that come to mind: dimensions, tolerances. What often we don't think about is how do you want the test to be performed to make sure you validate and ensure that the design and the parameters are maintained. Also, it's important when it comes down to safety, you definitely want to come in and talk about statistically meaningful sample sizes. Testing 1 or 2 samples is not statistically significant, as you know. So, and that is always a tough situation because depending on where you are in the development process, you may not have enough. So it's very important in the beginning when you outline these are safety concerns or safety critical elements to address, that somewhere in a test plan you identify the increased number of samples so the teams can plan to accommodate the validation that you're doing with all of this. And then it's extremely clear to have acceptance criteria that is very clear to make sure that the target is clear and that the decision can be made without really double guessing and of course, I would suggest that everybody reviews the acceptance criteria and buys into it, because plenty of circumstances where things fail and then suddenly the criteria is in question, which is not really a great way to solve the issue, but that's not uncommon. So coming to the same conclusion and agreeing is critical. And then also thinking about how do we propagate these requirements through the rest of the process as the design exits what I call the self-design phase before anything is tooled. What are we going to implement long term to maintain those parameters in play? I mean, there are many other elements of design process that those controls can be brought into. It's just that thinking systematically, just overall as a system of controls, to implement that throughout the process rather than hand them off and hope that somehow they'll stay in focus. I mean, it's critical not to let that fall off anyone's radar. And of course that we must include all of this to wherever we go, to a contract manufacturer, part supplier, or anything. We need clarity so that handoff is clean. And often it's not really a handoff; it's collaboration all the way through the process, so that there's back and forth. But keeping everything in the forefront, and that will really move things along much faster. But all this preparation will be worth it long term. Next, please. Here, what you'll see is just a sample of what a specs drawing could be. You clearly describe in this specification is, you got some tests that are used to validate what are the specifications that are to be met, procedures, and then also you got sample size that you're looking at. So those are important things to outline, as I mentioned earlier, having that clear in front as a test plan, as an expectation, and also the pass criteria, so everyone can align and plan for this accordingly to assure that all these are executed completely and successfully. Well, thank you. I'll pass it on to Mark.
Okay. Mark, are you there?
Yep, I sure am.
Okay, so we're going to start. Okay, so we'll go from the specifications to the supplier selection and evaluation. But before we do that, let me just ask Al a question. A lot of things, you've got the specifications. Obviously, you've got to follow up and be sure that they're meeting the specifications. How involved do you get in confirming that that they are meeting those specifications as far as the test methods and other things. I'll back up.
Yeah, so I think Mark will cover quite a bit of that, but generally speaking,
Okay.
this is a thorough process all the way through. So then generally safety engineers need to be involved end to end in these cases through production and also follow up with some post-production, post-mortem kind of evaluations to make sure that all the systems are set in place. But it's a continued collaboration with the development team back and forth, making sure that we're managing. And ultimately, you need to make sure that the intent of the controls are met appropriately. The solutions to control some of these issues may change and as the product is being developed, but you need equivalency through the process and then validating that through your testing, working through your supplier, making sure they also have control measures in place and verifying that that all adds up. And so ideally, right, you want the products and incoming inspection to come in with all the substantiating evidence that they do meet the obligations they were asked to per drawings and specs and all the parameters we defined earlier. So it's quite a bit of a system that needs to work in concert. But it's once it's set up and it's moving through, you can work through very complex cases very efficiently, and you have all the controls set up for long-term monitoring.
Okay. All right, Mark.
Yeah, thank you. So yeah, so as I'll say, it's a big deal that you set up everything on the front end. And I think one of the key things there is like Al was sharing, the specifications, the drawings, being upfront with those is really a big deal. One of the things that I like to do and suggest to folks is when you get in with a supplier at whatever level is build a relationship. And I don't mean that facetiously. I mean, you really have to get involved. And I like the concept of partnership versus supplier when you can, because partners have a tendency of being more tied to the result. They're more tied to the success of the business. And whenever you can develop that concept of a partnership, there's skin in the game. They want to develop something that meet their obligation under the thing, not because the law says or because a contract says, because they want to. And they're in this relationship with you. And I think that goes a long way. What helps is when you have a strong, robust set of requirements, you can go to your partner and say, these are what I'm trying to achieve. Do you agree? Can you work with me on this? Is this something that makes sense to you? The more nebulous it is, the more open and the more, the flexibility they have, the less one certain you're going to get what you want. But secondly, there's more opportunity for things to go sideways. So, and I'm not saying you got to tie everything down within an infinite detail, but I think you have to do what the safety professionals do best is do a hazard analysis, understand your product, understand the point of this component, understand its role and what it has in relation to the safety of the product, what can go bad, and tie it down commensurate with that level of importance.
Let me look. Can I just interrupt?
Yeah.
Why this is so important is that the contract is never going to be clear enough on who's responsible. I mean, it's impossible to write an indemnification clause that clearly says who's responsible for what. I mean, it never goes into that amount of detail. It usually basically says that you, component part supplier, will indemnify me, the OEM, if your component causes or contributes to the problem. And then you get the debate about who's responsible, whose fault was it. So it's never totally clear. So having a good relationship with your supplier and basically assume that, hey, we'll sit down and talk about this and we'll work out something that's fair for both of us. And we're not going to sit there and rely on the contractual language, which is extremely vague. So that's why this is so important. So don't rely on contracts and insurance to protect you. You don't want to have problems. That's our first goal, is to prevent the problems in the first place. Okay.
Yeah, that's exactly right. And we've been through that. I think most companies who've dealt with supplier issues have been through that, where you have to go and you have a problem and now you got to go work it out. Whether it's reimbursements, scrapping, rework, all those things are challenging and they can be costly and they can be tough. But when you have a partnership and you work with them, you have a better chance to get through that because now you both see the long-term picture. You're in it for the long haul, and that makes a difference.
Well, and the only thing that goes against that is the lawyers for the component part supplier don't want to do that.
Nope.
We just want to say, hey, I'm going to sell you the component. if there's anything wrong, we're not responsible for anything. You're taking ownership of that component in your product. We're not responsible if anything happens. That's what the lawyers are going to say. Then the question is, do you as an OEM want to buy from the supplier who takes that position? That's the tension that goes on there. But that's certainly what Mark is saying. That's your goal.
Exactly. And that's why you want to get a partner if you can. Make them,
Right.
and I love the concept of making them part of our project team. And that makes it, and there's things that go with that, right? You got confidentiality issues, you've got some documentation issues that you're going to want to, make sure that you're preserving some secrets and things like that. But the more you can get them embedded into the design to the extent that when you're specifying a part, one, it's the right part. Two, they're the right supplier for that part. They understand their role. They see it as a part of a bigger picture, not just a contract, not just a PO. So it may or may not matter, but I think it's better to go in with that if you can, and it will, in most cases, end up becoming a better result. And if nothing else, no harm, no foul. It didn't do anything, but at least you were prepared in case something went wrong. Okay, so let's go to the next one. And so I love this concept of what I call meet with a purpose. It's similar to like moving with a purpose. I want to go somewhere. I can run circles and burn a lot of calories, or I can go from point A to point B and use the same amount of calories, but actually accomplish something. Let's go accomplish something. So when you want to accomplish that, meeting with that supplier is really framing up what you're trying to accomplish with them. And I mean, really, really get them to understand what good looks like. Okay, this is what we're trying to accomplish with this part, with this product. This is what we needed to do. This is what this relationship needs to look like. This is what our supply looks like. I need you to develop 10,000 a week, 10,000 a month. I need them on time. I need you to do a buffer stock. I need you to do an exclusive, whatever those are. Really get those on the page right off the bat, because if you start with those, everybody's on the same page from day one. And if there's a problem, you address it up front. You don't want to go through, get the right part, love it, get it in, it works great, and then find out you can't work with your supplier. No, you go backward. Your product's now in jeopardy. That's not the way you want to go if you can avoid it, especially from manufacturing perspective, because you have deadlines. You might have customers you're going to sell product to. They're expecting product on a shelf, and you don't want a supply chain issue to become the problem. So those are addressable issues. Again, when you bring people onto project teams, things like non-disclosure agreements, become a big deal, whether it's a one-way or a two-way. Work with your lawyers to figure it out. But what you're sharing back and forth, what you're going to give, what you're going to get, really makes a big deal. Intellectual property can kind of be into that same ballpark if you're not careful too. If they're developing parts for you, if they're doing things with you, there could be some joint development stuff. So again, work really closely with understanding the scope. And then you can work with your legal team and their legal team to make sure that you're outlining all those important features up front so everybody agrees, yes, we can do this. Yes, we want to do that. And then we can put the legal framework behind it so you can go do the job. You can't do that on the back end. It doesn't work. So really get that involved. And then when you get there and you're ready to go, the things Al talked about, those specification drawings become so important. This is what I needed to do. This is what I wanted to do. This is what I'm asking you to deliver. This is what I need you to be able to do. Will you do it? Can you give me what I want? Can it be the cost? Do you have one thing we looked at, and there's some things we're going to talk about in a little bit, but do you have a supplier quality plan? How do you manage the quality? Does it meet something that I would consider to be representative of what a good manufacturer would do? Because that stuff is going to be important, because we can sit in a room and talk nice. We can go to dinner and have a great meal. And everybody could be best friends walking out of that. But at the end of the day, that relationship has to be delivering on a good product. Everybody has to succeed. So again, starting with what good looks like gives you a great chance to get there. So the next.
One thing to point out on the friendship that you have with your suppliers and the partnership is, at least in case of a product liability lawsuit, you're not dealing with your partner, the component supplier, you're dealing with their insurance company. And they don't really care what your relationship is with them. They're going to fight tooth and nail to blame you, the OEM, for the problem caused by the component part. So there's nothing you can do about it. You have a relationship with your supplier, and you hope in the event of a problem that you're protected. But just understand that it may not help in the event there's a lawsuit because you have somebody else involved.
Yeah, it's a really hard thing, and it's a corporate decision you give yourself a chance to make. We've got suppliers that when we get in liability, we could get them involved. We could go to a third party action. We choose not to, but that's a choice we get to make. But that's because we've built the relationship. In cases where we got the insurance coming at it, they know, hey, look, insurance is doing this, not me. I'm not your friend is not coming after you in court. My insurance company, there's nothing I can do about it. But at least we know where we all stand. So it's a big deal. So the next slide, please. So, did we miss one? Oh,
Yeah.
nope, that's the one. Okay, sorry about that. So this is kind of what I use and we use here at our place is a little bit of a flow chart is to, when you select a candidate, one, we love to see them do a self-assessment. We like to see what do you think of yourself? Where do you think you stand? You think you're a top tier supplier, you think you've got quality nailed, you think you make the best thing, and you've got everything buttoned up. And we're going to talk about that. And then we're going to go look and compare what we get. And we're going to say, well, we looked at you as well. And from what we're seeing is, yes, we agree with you. Or you're in part, we agree with you. And in part, maybe we could do a little better. And here's where we need to go better. And that where you get into that decision box is like, all right, are they willing to do better? Are we able to work together to make this something? Or are we kind of dead in the water here? And you got to figure it out. And then they make decisions. We document our things. We move ourselves into a place that we think is good. Now let's go do some audits. Make sure that we validate. And I'm a big fan of validation audits. If you audit for the first time at the end of the stage, you're probably making a mistake just to the extent that you've had a chance to see something, you've had a chance earlier and you didn't take advantage of it. So it's not really a validation anymore. Now it's an initial audit and you probably got a problem. So these pre-meetings, these pre-assessments, those early opportunities become kind of mini audits in their own way. And that gives you this opportunity to pick something up, figure out how to make sure that they're doing it well. They made changes. You can measure against what you think, they should have been doing and see whether those changes are going to be effective. And you can move yourself forward. So validation is exactly that. It should be validating what you already know to be true or believe to be true. But if you're learning at that point, it might be a little late. It depends on what you're doing. And so when you go through those audits and you do those things, when you find problems, and you will, have a robust way to deal with them. We score things on a 1 to 3 basis. 3s are really big deals. We do not go forward with those. 2s are pretty big deals. We got to figure it out. 1s are usually kind of findings, but we can work through them. We need corrective actions, but make that a point that these are not just going to get put in a file. You, supplier, as we talked about earlier, are going to make these changes. We're going to get better. You're going to fix these deficiencies. And we agreed on that. And as my partner, you're going to go do that. And just keep kind of working through it. But this is a kind of a way that we spend a lot of time and think is a reasonable way to get through what we think is a challenging process sometimes, but an effective one, because at the end of the day, our name is on the product. Our brand is at risk. So we need to do what we can to make sure that we're comfortable as much as if we were making it ourselves. Okay, so next. So one of the things we love to do is set up also a part of our audits is a test plan. Okay, we don't just audit and walk around and watch people do things and measure things and do checklists. That there's certainly some of that that's important, but we also love to do test plans. And one of the thing about test plans is that when you do, especially a component like an electrical component, those very often have ratings and they're built off of some set of standards, whether it be a product standard from UL or a safety standard or what have you. And they're typically meant to say, yep, this component can carry this much energy or can hold this much temperature, it'll deliver this much liquid, whatever the answer is. But it's almost universally not set up to check exactly the situation you're in your product. So it's really kind of important to look at the product you have, know what needs you're asking that component to meet. You believe those specifications gave you a chance to say, yes, I picked the right one. But now I have to go exercise that to see is it really going to be effective in this thing? So set those goals. Figure out where you're going to do it. Am I going to do it? Am I going to have the partner do it? Am I going to send it to a UL type lab and have them do it? Or a third party just evaluation center? I don't know. What do I need to do? These are all important. One of the key things I think that most people miss is the method. So when you get down to the test definition, we've seen a number of people that will test to UL and they'll do the minimum of something in UL, and then we'll come out of it and say, well, UL gives you this option and we like it that way. And like, well, we didn't do that. Get that up front, get an alignment on what that method is. So when you get the results, you can measure them against an acceptance criteria. You're on the same page every time. You know, scheduling obviously makes a difference. So make sure you got stuff in time to do that and do a good analysis so that you don't end up running into timing issues. And then make a decision. All of this data, all this information, all these conversations put you in a great place to make a decision. So now it's time to go make one. Next. And once
Okay, let me just point out. Okay, Mark, we got two questions, which we'll do at the end. So if you can finish in about 4 or 5 minutes, that would be good. And then we'll take the two questions and we'll finish on time.
Absolutely, no problem. So after you've got all this stuff done, we're happy, we're moving forward, then we go back and audit. And I like to consider things like a 3-phase audit process. I like to audit the product, make sure it's right. That's part of the testing we talked about. Audit their process. Can they make it? Can they make it consistently at rate? Audit the system. Is it controlled? Are their suppliers controlled? Are everything going in right? So again, go as deep as you need to go, but making sure that those things are done is a big deal. So it's not over just because I made a selection and made a decision. Okay, next. You know, and when I go through these, you know, one of the things is there's always multiple functions. So maybe it's not one visit, maybe it's multiple visits. Maybe it's not the same person. Maybe there's multiple people. Maybe there's multiple things that have to do. Fine. Plan for it, set it up ahead of time, be ready to go. Okay? Okay, next. And be prepared that this is, again, not a one and done. This is not something I do, make a decision and move on. You might have to have ongoing quality. It's not uncommon to hear the concept of the golden sample or the golden pencil. There's always going to be a great one. Everybody's going to give you your best effort on the front end. Can you actually make it 10,000 times a week, every week for a year, and make it with that level of quality? And can you do that? Have you done the right things? Which means you got to monitor and find out if they're doing their job. So don't stop just because you've made a decision. You got to keep looking at it. A lot of factors can go into it, but you got to keep after them. Okay,
yeah, we've had that problem lots, particularly products coming out of Asia. Whether it's that they give you the golden product at the beginning, or they change the material after they give you the sample to save money, and they don't tell you about it or get your approval. So you have to be very careful, particularly when the components are being made offshore.
Absolutely, and really, it's components and materials are big. Watch process. People can go faster and make plastic parts faster if they increase the temperature and mold pressure. You can embrittle the plastic and make it garbage. So they're now delivering 15,000 a week, but you're dealing 15,000 a week of garbage. So watch that, understand the parameters. So when they want to make those changes, you can say, nah, I don't think so, because it doesn't make sense because you're going to make a problem. Or let's validate that change before I let you go full production on it, because it can make a huge difference. Okay. This slide, I won't read through it, but I think it's important to tie back your company culture, the fundamentals of what you want to do, and some of the elements of these programs, and make sure that your quality management system has a framework that's got enough maturity. And if it's an ongoing effort, fine, build toward this level of maturity, but it gives you an opportunity to look at all sorts of things that are important to these decisions and to this ongoing quality, and making sure you're attacking them in a meaningful way. And if you don't have it, fine, work with experts, work with people who know, build toward something like this, but make it right for your business. You know, and you don't have to. It can be hard. It can cost money, but it's real, and it pays dividends if you do it really well. Okay. And then last, I think we talked a little bit about it earlier, but work with your legal professionals and make sure that your supply agreements, to the extent you can, cover all the key things, all the key specs, the things that you want to deliver, all of those little things that you talked about in your discussions. Get them on paper. Will it support everything? Will it be completely clear? Can it be completely legally defensible? Will you still have arguments? Yeah, maybe everything's going to be great. Maybe it's not. But you will give yourself the best chance to handle this by working with quality legal professionals and getting a really good agreement, so you're on as good a page as you can be. And then see where it goes. But I think that gives you a great chance to succeed.
Well, and let me say from the legal side of it, be careful that your lawyers aren't too careful and too cautious, because you'll wind up never having a supplier who wants to sell to you, because you're trying to shove liability off on the supplier when it really isn't called for. So you want to be careful, to have them be realistic about the relationship you're developing. And to a certain extent, we're relying more on our good working relationship and not going to meet the exact language of that contract. Okay, let me get a couple questions and then we'll be done. How should the conditions of acceptability be addressed? This is a concept that is not very well understood by many design engineers, procurement, and other members of the organization. There is a misunderstanding that any RTL certification is sufficient. I assume you guys know what that means.
Yeah. So if I can take a step at it, I think it's very much connected to Don's question that follows. In my mind, this goes into the responsibility of the integrator. The integrator is the one that assembles these components into finished product. And so the obligation in my mind is the integrator has to be aware of the component limitations and be aware of that and verify that they have all the information to make a sound design choice, integrating them in the product. But on the other side, also, you need to have the components manufacturer coming in and truly outlining the boundaries of their design capabilities. So there's a clarity on how it fits into the overall design. Now, RTL, right? So you get a certificate from UL, CSA, or whoever. That is only for the component itself as it stands alone. Like if you have a cord or a motor or a switch, but that's to itself. It's not to as it's integrated in the final product. So again, that obligation percolates up to the integrator. And so you can have a 100-watt or 100-volt or whatever 100-amp rated switch, and then you need to make sure that your device will not exceed those specs. Things like that. I mean, just being sure, because ultimately, yeah, you can go after the component supplier for defects, but the integration ultimately is squarely in your court.
Yeah, I agree with that, Al. And I would add one thing that, remember, conditions of acceptability can be limitations, exactly as you said. They can also be things that we did not test it as part of the component evaluation. We didn't go that far. So now it's giving you insight into things you may want to exercise and learn about because the UL guy didn't know. It didn't have a final housing. It didn't go into a block. So they don't know what that is. So they give you those conditions. So take those very seriously and make sure that you're considering them when you put them into your integration and you integrate them in, because that is a insight into what they did. They don't know. And so go learn and know before you go and say yes.
Yeah.
Okay, the second question, who should be responsible for compatibility between the component part and the final product for which it's intended?
Pierga. Absolutely. But that's a great question. And I think at the end of the day, the product developers really, and the integrators, as Al called them, which is a great term, really have the responsibility. You're the end product designer. You know what you're trying to develop. And I think your component selection and your use of a component in a way is really on you as a developer. It's component. If you pick the right one and they make it the right way and they do all the things we talked about, but you picked a bad one, you can't blame them. You blame yourself. So you really got to make a good choice. So I think as long as you're getting what you expected and all this stuff, it's on you. If they fall apart and you had a bad supplier and they make bad stuff, well, then you can go talk to them about it, but you still might have just made a bad choice because you picked the wrong partner.
Yeah, let me just give you one classic example of this exact point. An infamous case where DuPont sold Teflon to a jaw implant manufacturer. And DuPont told the manufacturer, we're not sure if Teflon's appropriate for use in a jaw implant. We expect that you're going to do safety analysis to be sure that the Teflon is appropriate to use in your product. And the OEM said, okay, we will do that. The OEM didn't do that. They put the Teflon in the jaw implant. It caused problems. And the manufacturer, the OEM, got sued. After one verdict against the OEM, they went bankrupt. And who got to defend the rest of the cases? DuPont. So DuPont, it cost them millions and millions of dollars in legal fees to defend the cases. They didn't lose any case because they didn't do anything wrong. But the trouble is the OEM went bankrupt. So who's responsible for compatibility? It's a joint exercise. And whichever side you're on, you want to be sure that it's the right product in the right use, it's installed correctly, the warnings and instructions are adequate, because you're both going to be responsible, and you don't know what's going to happen in the future as to far who can get sued, or where the recall is going to be, or who's paying for what. You just don't want to have the problem in the first place.
I think that's a great point. And I think you're going to see that relevant in things like batteries these days. Everybody makes a battery, but not every battery is meant for every opportunity. So be really careful if you supply those things to people, and make sure you know what they're doing with them. And integrators of your parts know what the heck, and to the extent it's a big deal.
Okay, well, thank you all very much. You see on this slide, if you have any questions concerning what we said or what we post, you can email us. I see all the emails. I'll get you the answer. If I can't answer it, I'll find somebody to answer it. And the slides will be available in our webinar archive. And we thank you all very much. Thank you, Al. Thank you, Mark. I appreciate your contributions. And we hope you enjoy the rest of your day. Thank you all.
Thank you, everyone.